Okay, we are getting started here with chapter 11, which deals with conic sections. Conic sections are basically the cross sections of a cone when you slice it. Okay, so I'll probably put in another video at the end of the conic sections so that you can see what I mean about the slices of a cone. Okay, so 11.1. We're going to start off with the parabola. Okay, so we've looked at the parabola in terms of the quadratic, so we're going to revisit it, but we're going to focus on different aspects of the parabola. Okay, so let's talk about the definition of a parabola in a geometric sense. So a parabola is basically the set of points in the plane that are equidistant from a fixed point F, okay, which is called the focus, and a fixed line. A fixed line, call it L, which is called the directrix. Okay, so if this definition seems a little confusing, I will do a visual here for you. Okay, so what this is essentially saying is that you have a fixed point and a fixed line. Okay, so suppose that's my fixed point, and suppose that this is my fixed line. Okay, so this is my directrix, and this here is my focus. Okay, so all the points that are equidistant between these two objects, the focus point and the directrix, any point that is equidistant to it is going to be a point that falls on the parabola. Okay, so we have this point right here, which is directly in the middle. So the distance from this point I just drew to the focus is going to be the exact same distance from that point I just drew to that line. Okay, so that point will be on the parabola. Okay, if I take a look at, looks like maybe this one right over here, right? And if I take a look at the distance there, okay, so the distance of that point to there and from that point to the line, we see that it's the same, right? It's equidistant. Okay, so that point is on the parabola. Okay, this one over here looks like a point on the parabola because we see that the distance from this point to the focus, that distance looks like the same as the distance to the line. Okay, so that point is on the parabola. Okay, and looks like maybe this one is equidistant as well. So that if I take a look at the distance from that point to the focus, it's that long, and the distance from that point to the directrix, and those are equidistant. And so we can keep doing this until we come up with a collection of points. So right about here, and we see that that one is also equidistant. This distance is the same distance to there. Okay, so if I picked a point like, say here, this red point, clearly that's not going to be on the parabola because it's a shorter distance to the line than it is to the focus, right? This red point is farther away from the focus than it is to the directrix. Okay, so that point, that red point, is not going to be a point on the parabola. Okay, and we all know what a parabola looks like. And so we see these 5 points that I've just drawn start to form the shape of a parabola. Okay, so that's the geometric definition of a parabola. Okay, this here, this distance, let me use a different color. This distance over here between the vertex here, this is some distance, and I'm going to go ahead and call it P. And of course, this distance over here is also P, right? Because it's equidistant. Okay, and that's going to play an important role in this section. Okay. So let's take a look at the equations of the parabola. So we're going to look at a different way of writing it. In this particular section, we're going to be looking at the equation where it's written so that the square is the one, it's solved for the square. So the square term is by itself. Okay, so we're going to look at this form of the equation. Okay. All right, when it's written in this form, then we can tell a lot of things about it. Okay, so when it's written like this, we know that the vertex is at 0, 0. We know that if P is greater than 0, if it's positive, then it will open upwards. Okay, if P is negative, less than 0, then it will open towards the negatives. So that would be downward. Okay, and now the focus and the directrix become the main characters here in this section. So here, the focus will be at the point 0, P, okay? And the directrix will be the line y equals negative P, regardless of what P is, okay? Regardless if it's positive, negative, these last two will remain, okay? So in general here, if you look back at the drawing, we can see here that in general, these two things, the focus and the directrix, are P units away. So these two things are P units away from the vertex. So you can easily graph those two things, the focus and the directrix, when it's written in this form, and you can identify P, okay? So let me just do some drawings here. Okay, so again, if P is positive, then you will have a parabola that opens upward. Okay, so vertex at 0, 0, and it opens upward. Okay, and the focus would be over here, P units away, wherever that is. And the directrix would be equidistant, P units away, down here. Okay, and the equation of this line would be y equals negative P. Okay, now for a negative P value, then we would have a parabola that would still have the vertex at 0, 0, but now it would open downward. And the focus would now be down here, still at 0, p. Okay, because remember now, p is a negative number, so just plugging in p there will still work. And your directrix would be equidistant, so p units up here, okay? And it is a line. Okay, so, and this line would still be y equals the opposite of whatever p is, okay? So so far in this class, we've only focused on parabolas that open upward or downward. So now in this section, what we're going to do is we're going to also take a look at parabolas that open sideways. Okay, so here, in this case, the y is the one that's being squared and not the x. Okay, so it's written like this. We still have the vertex at 0, 0. Later on in, I think, 11.4, we will take a look at all of the conic sections again, where they aren't centered or the vertex is not at 0, 0. Okay. So here the vertex is at 0, 0. And if p is positive, it will open towards the positive sideways. So it opens to the right. And if p is negative, then it opens towards the negatives, which is to the left. Okay. And your focus will be at P0. And your directrix is still a line. But now instead of y equals negative p, it's going to be x equals negative p. Okay. And again, as far as these two go, in general, these two things are still going to be p units away from the vertex. The only difference now is that instead of going up and down, you're going to be going left and right p units. Okay. So here, I'll draw what that would look like. So when you have a positive p-value, then you have this. Okay, so vertex still at 0, 0, but now because the y is being squared, we have this sort of sideways parabola. Okay, and our focus is p units away. Okay, so wherever that is, this is your focus. And so that is at P0. And then over here, equidistant, P units away this way, you have your directrix. Okay, and the equation of this one, we can see here, that's a vertical line. So it's x equals, and it's at negative p. Okay, and if p is negative, we have this sideways parabola, but now it will open towards the negatives. Okay, and we still have our focus inside the parabola, and it is here at negative, it's still at p. P is negative in this case, so we don't have to say negative. P0. And then the directrix is over here, p units away from the vertex. And it is a vertical line. So it has the equation x equals negative p, the opposite of the negative p. Okay. Okay, so let's go ahead and take a look at some examples. Okay, so let's go ahead and find the equation. Find the equation for the parabola with vertex 0, 0 and focus 0, 2. And let's go ahead and sketch the graph. Okay. A lot of these problems will say, and do all of the following and sketch the graph. So I actually like to start the problem with sketching whatever clues they give me. Okay, so because the clues that they give you, it's a lot easier to see what sort of information you have visually. Okay, so let's graph the information that they give us. The vertex is at 0, 0. Okay, great. And the focus is at 0, 2. So that alone already tells me so much. It tells me that my parabola opens upwards, which then, if it opens upwards, then this tells me it's this kind of equation, and my p is a positive number. What is my p-value? Well, remember that p-value is this distance between the focus, okay, between the focus and the vertex. Okay, so we can see that. We can see that it is 2. Okay, so we see that P here is 2. So all I have to do is plug in that P value and I'm done. That's my equation. Let's just write it as 8y. Okay, so that's why it's nice to draw the information that they give you. Okay, so remember we started off with just this, right? All we know is that the vertex is at 0, 0. Okay, and the focus is at 0, 2. Okay, this is our focus, right? And we know the focus is always inside the parabola, so we know it does this. Okay, so we know it does that. From that, then we know this, right? We know it's going to be that equation. And then all we have to do is count to find out what P is and plug it in there. Okay. Okay, let's try this one. Find the focus and directrix of the parabola y equals negative x squared, then sketch the graph. Okay. All right, so let me bring that equation down here. This is the traditional way that you are used to seeing the equation written. But again, in this section, we have it so that the x squared is by itself. So let's go ahead and divide both sides. Let me go ahead and first switch them. So it's negative x squared equals y. And then we have to solve for x squared. So x squared equals negative y. Okay. All right. So the x is being squared, right? So we know it's a vertical parabola with the vertex at 0, 0. Okay. And because it's a negative p-value, okay, so here let's go ahead and solve for our p-value. Okay. So we know that 4p equals this negative 1. So p equals negative 1/4. Okay. All right. So we know that it is this kind of parabola, opens downward. Okay. And we know that the focus will be 1/4 away. There's my focus. And my directrix will be 1/4 away. Because remember, they are both p units away from the vertex. Okay. So my directrix has the equation y equals, remember, horizontal lines are y equal constants. So y equals 1/4. And my focus over here is at 0, -1/4. Okay. And it asks us to find the focus and the directrix and sketch it, and we did. Okay, let's take a look at this next one. Okay, so suppose that a parabola has the equation 6x plus y squared equals 0. Okay, let's find the focus and directrix and sketch the graph. Okay. All right, so let's take that equation and let's get that equation written in that standard form where the x squared or the y squared is by itself. Okay, so I'm going to subtract 6x on both sides. So y squared equals -6x. Okay, so this is our standard form. And then right here, I'm going to find our p value. So 4p equals -6. So p equals to -6/4. Which is -3/2. Okay. All right. So we know y is being squared. So we know that it's a sideways parabola, right? Y is being squared. So it's a sideways parabola, vertex at 0, 0. Okay. The p-value is negative. So we know it opens towards the negatives. Okay. And we know that p-value is -3/2. So my focus is right here. Okay, so my focus is at the point -3/2, 0. And I know that my directrix is over here. Okay, so my directrix, okay, so my directrix here is y equals -3/2. Vertical line, oops, sorry, vertical line is x equals -3/2. Okay, positive. That darn motorcycle. I'm going to blame it on the motorcycle. X equals +3/2. Okay, so that's my directrix. All right, let's see. Okay, let's do one more. Find the equation of the parabola that has vertex at the origin. The origin is 0, 0 at the origin and directrix x equals 2. Okay, so whenever they're asking you to find the equation, start off with the graph, okay, and see what you have. Okay, what do we know? Vertex at the origin. Okay, great. Vertex is right there. Directrix is at x equals 2. 1, 2. And here is my directrix, which tells me that my parabola opens to the left. Okay, and I know where my focus is going to be because it is equidistant. So if the directrix is 2 units away, then my focus is also 2 units away. Okay, so, but I don't even need that to write the equation. I already know everything I need to without the focus. I know that it's going to be this kind, okay? It's going to be the y squared because it's a sideways parabola, okay? And I know my p-value, right? My p-value is this distance right over here, which is 2 units, okay? So I can plug in 2 for the p-value. And that's all I need to come up with my equation. So y squared equals 8x. Okay? All right, so that is pretty much it for 11.1 parabolas. And when you do the sketch, it's just a rough sketch. If you must have exact points, here's something. If this is 2 units away, then over here, the distance from the focus, okay, so if this here is 2p units away, whatever it is, then the distance from here to the parabola will be twice as long. Okay. So you can get another point on the parabola if on WebAssign they're asking you for exact points on your parabola. Okay. So if that's 2, you'll have a point at -2, 4. Okay. All right. If you have any questions, make sure you email me or you send me a text.